Hi, this is Dr.G.Vikas Paul. In this session, we'll see a problem on a horizontal beam, simply supported beam subjected to a moment. So we need to find the deflections and slope. So let us see the problem. A horizontal beam AB is simply supported at A and B, 6 meter upon a span. So A and B, 6 meter span. The beam is subjected to clockwise couple of 300 kN at a distance of 4 meter from the left end. So 300 kN per meter, 4 meter from left end. That means AC is 4 meters. As shown in the figure. Take E equal to 2, Young's modulus is 2 into 2 power 10 power 5 Newton per mm square. Moment of inertia is 2 into 10 power 8 mm power 4. So we need to determine the deflection at the point where couple is acting. That means at C. What is the deflection? So YC we need to calculate. C is not exactly at center. Okay, it is 4 meter from A. And next, the maximum deflection. So where is the maximum deflection? We don't know. We need to calculate the Y max value. So first of all, this is the figure. So in Macaulay's method, we'll use the differential equation, that is m equal to ei d square y by dx square. So considering a section xx at a distance of x from A, so we are considering a section xx at a distance of x from A. Ra and Rb are the reactions. Okay. So here m equal to ei d square y by dx square. M is nothing but mxx. So moment at this point we need to calculate. To calculate this, we need Ra and Rb. We need to calculate Ra and Rb first. So to calculate Ra and Rb, we will apply sigma mb equal to 0 and sigma ma equal to 0. Applying sigma moment about b equal to 0, so Ra into perpendicular distance and 300. So Ra into 6 plus 300. So clockwise, so plus plus. So we have got Ra equal to minus 50. Applying sigma moment about a equal to 0, so Rb into perpendicular distance, this is anti-clockwise, so minus Rb into 6 plus 300. So from here we have got Ra and Rb values. Now mxx, so if you see the left side part, so Ra into x plus 300, Ra into x plus 300 are the moments. So we should equate this to this one, ei d square by dx square. Equating this, we will get this one. Okay, substituting Ra value minus 50, we will get this. Let it be first equation. So integrating that equation number 1, we get this one. And we will get a constant C1. X square by 2 x plus C1 dy by dx. So d square y by dx square becomes dy by dx plus C1. This is, let this be equation number 2. Integrating this equation, we will get see x cube by 3 here, x square by 2 here. This becomes y and C1x will come plus C2. Let this be equation number 3. So to find this C1 and C2 values, apply boundary conditions. So what are the boundary conditions here? See here, at A there is no deflection, at B there is no deflection. X is the distance, this distance from section. Okay. So at x equal to 0, that means at A, deflection is 0. At x equal to 6 meters, y equal to 0, deflection is 0 at A and B. So at x equal to 0, y equal to 0, at x equal to 6 meters, y equal to 0. These are the boundary conditions. Let us apply first x equal to 0, y equal to 0. So at A, that is x equal to 0, y equal to 0, substituting in equation 3. Okay, substitute x equal to 0, y equal to 0 here first, then we will get C2 value 0. Now at B, x equal to 6, y equal to 6, substitute in equation number 3. What we will get? X equal to 6. See here, wherever x I am substituting 6, wherever y is there I am substituting 0, then I have got this one. So from here I have got C1 equal to 600. So substitute C1 equal to 600, C2 equal to 0 in equations 2 and 3 to get slope equation and deflection equation. So if we substitute in equation 2 the value of C1 and C2, we have got, here we have substituted, we have got this equation which is known as slope equation. If we substitute C1 C2 values here, we will get deflection equation. Okay, now he is asking to find yc and y max. First we will find yc. To find yc, substitute x equal to 4 because it's center, that means, sorry, not at center, yc means c is at a distance of 4 meters from A. So x equal to 4 meters we need to substitute in deflection equation. So here x equal to 4 we need to substitute, then we will get yc. So substituting x equal to 4, we will get this one, yc. So by solving, you will get yc as minus 1.328 into 10 power minus 11 mm. Okay. Next, to calculate y max. So now, how to find y max? See here, we don't know what is x value to find y max. So there is y max will be at some point, but we don't know this distance, x distance. So we have a logic here that at maximum deflection, slope will be equal to 0. So using this condition, substituting theta equal to 0 in equation number 4, in slope equation, we can find x value. Substituting that x value in deflection equation, we will get maximum deflection. So here, this is y max. To find this x distance, substitute theta equal to 0 in slope equation. So substitute dy by dx equal to 0 in equation number 4. So in this equation, I am substituting theta equal to 0. Then I will get this equation. Okay? dy by dx equal to 0. Then we will get this quadratic equation. So we know that it is in the form of ax square plus bx plus c equal to 0. Here a equal to minus 25, b equal to 300, c equal to minus 600. How to find the roots? We have a formula minus b plus or minus under root b square minus 4ac. Yes, using this formula we can find the roots. We will get two values. So x can't be 9 because the total span is 6 meters. So cancel it. So x equal to 2.53 mm. 2.53 meters. 2.53 meters. So substitute x equal to 2.53 in deflection equation, we will get y max. So substituting in equation number 5, we will get y max equal to this one. This is the maximum deflection.